just joining us in this class, you need to know that we have done the introduction of all the stops you can see on the board. And then we've given you the acronym or the formula for you to know all those scalar quantities that you can, which is mass, t, speed, work, volume, and kinetic energy. And you can see the meaning of all of those. Now, we also have that we begin to differentiate between vectors and scalar. We told you that scalars has magnitude, no direction. Vectors has magnitude and direction. And in our previous class, we told you the reason why vector area is a vector, angular position is a vector. We illustrated the reason why these things are vector. And we illustrated the reason why all these quantities here are vectors. You can check out that class, Vectors and Scalar 001. This is Vectors and Scalar 002. All right, now in this class, what we'll be looking at, let's add more vectors here. So displacement is also a vector. Yeah, displacement is the change in x, which is x final minus the x initial. So you can be able to differentiate a vector and a scalar using this medium. All right, let's ask ourselves some certain questions. If you have a question that says, which of these is a vector? Which of these is a vector? You have A, you have altitude, you have B, you have power, you have C, you have velocity, you have D, you have speed. So which of these is a vector? Question number one. Question number two, we'll say which is not a type of scalars. Which is not a type of scalars? We have A, we have force. B, we have momentum. C, we have impulse. Or we have area. Which of these is not a scalar? Then we have area, and then we have D, we have A and B. All right, so we have this question, which of these is not a scalar quantity? Of course, the answer is force and momentum, but I leave you to answer the question for yourself. Now, have another one. They will give you a list of stops. Kinetic energy, 2, momentum, okay, 3, altitude, 4, power, and then 5, that will give you impulse. Now, they can ask you a question, which of the least is a vector? So we want to know which of the least is a vector and which of the least is a scalar. So this other question will come. So we have, I'll give just two options. Which of this is a vector? I have I and I. Let me give you three options. B, we have I, and IV. So which of the least is a vector? So I have the C there. I have I have and I have V. So which of this least is a vector? So finally over there, which of the least is a scalar? I have over there I and V, which is option A. Option B, I have V and I. Option C, I have I and I and IV. Now, let's pick up the first question. Which of these is a vector? Now, altitude from the list of the vectors with scalars we have here, altitude is there. So altitude is not a vector, although I've told you why altitude is not a vector. Power, you can say power over there among the scalars. Power is not a vector. Then velocity, definitely velocity is a vector. Displacement over time. So this is the answer over there. Speed is over here. It's not a vector. So we have there, which of these is not a type of scalar? Force is vector. Momentum is vector. Area is a scalar. Now, which of these is not, you understand the question, is not a type of scalar? Of course, area is a scalar. A and B is not the type of scalar. So we have this over there. Now, you have the list. Which of the list is a vector? I and I. I and I. I is momentum. Altitude is a scalar. Where's the altitude there? All right, it's a scalar, so it's not a vector. Power, we have I, okay, momentum, I, altitude. No, that's not the answer. We have I, momentum, IV. So this is the final answer. So we have this one, scalars. V over there is impulse. Impulse is a vector. V over there is impulse, is a vector. So the answer should be definitely I, and IV. So this is the answer to that question. These are the questions will appear when you want to identify vectors or scalar. Let me give you a quick one. Let me give you a quick one. Let's say we have okay, let's say we have what or which of these units, which of these units is a vector? Now, which of the units is a vector? You have A, you have Newton meter, you have B, you have Newton meter square, you have C, you have Newton seconds, you have D, you have S is equals to D over T. Now, which of these is a vector? Now, you need to know, or go back to the video where we taught on units, derivation of units. Now, you need to know what Newton meter means. What does that mean? If you notice, work done is equals to force times distance, and that is Newton meter. And work done is not a vector, it's a scalar because it's among the mag, t, speed, and stuff. So we have prayer. Prayer is force over area, which is Newton meter squared. So this is the unit for prayer. So prayer definitely is not a vector. So we have this guy there, which is Newton seconds. If you look at impulse, impulse is equals to force times change in time, and force is Newton times change in time, which is seconds, is Newton seconds. So definitely the answer, let me use the red pen now. The answer is this guy. Now over there, this is distance. Distance is equals to, speed is equals to distance over time. So definitely the vector is this guy. This is the form in which your questions will appear. I've given you the 4 list of questions. If you can understand the 4 list of questions, there is no question you cannot answer under identifying vectors and scalars. In our next video, we'll be dealing with the formulas that is required to solve vectors and scalars. See you there. Have a nice day.